everyone. I'm here to present our group's truth table. We have inputs XY, A, B, C, D, and input EF. Traditionally, we get a traditional kind of truth table for the inputs XY, while as we notice here, inputs A, B, input C, D, input EF, all got the same value as we look at this truth table. And also corresponding to that, we get outputs, output 1, output 2, and output 3, all corresponding to the two preceding inputs that were made. As in, inputs A, B correspond to output 1, input C, D corresponds to output 2, and inputs E, F both correspond to output 3. Well, when we look at this truth table, we get a representation for this part of the truth table, an inverter. For this part of the truth table, we get a representation for an AND gate. While for this part of the presentation, we get a representation for an OR gate. While for this part, we also get an OR gate. And then for this part of the truth table, we also get an AND gate. And then finally, for this part of this truth table, we get a representation for an inverter again.
This is our K-map based on the truth table earlier. So this one is the K-map of output 1. So these are the groupings based on that, and which shows us the equation of xa prime b plus xy prime a plus x prime yab plus y prime a prime b. And as for the output 2, this is our K-map, which shows these groupings, which gives us the equation of xy prime c plus ycd plus y prime c prime d. And as for the last output, which is output 3, this is our K-map, which gives us the equation of xe xf y prime e prime f plus yef.
This is the combinational circuit we have for using the K-map we have solved earlier. So once see there's no input C, D, and EF because the input of C, D, and EF is also equivalent to AB. Now, in the output one, you can see there are 4 AND gates and 2 inverters for the output 1. Then, the output 2 consists of 3 AND gates and 2 inverters. And the output 3 consists of 4 AND gates and 2 inverters also. This is the combinational circuit we have for.
This is the simplified version of the logic diagram from the previous video. As you can see from here, this was the original drawing of the logic diagram. So from the K-map, we have simplified it by reducing multiple terms. This, like this one here, from the output of 1, y bar, a bar, b. There is also a y bar, a bar, b in output 2 and output 3. So we just made it a single one and distributed it from the to the other outputs. And also with a
Ilang points pa kailangan mo dyan?
y, a, b, and here, y, a, b, and then x, y, a, x, y, a. So this is the simplified logic diagram. The reduced form of the logical circuit diagram. So I will simulate it. At the right is the truth table, and at the left is the logic circuit. So at min term 0, output 1 and 2 and 3 are all x, and at output 1, I mean min term 1, all the outputs are 1, and output at min term 2 there are x, 3, 4 is 4, up to 6 should be zeros at all outputs. So this is 4, 5, 6, and then 7 should be all ones. 8 should be all zeros. 9, 9 to 11 should all be ones. That's 9, 10, 11, and then 12. Output 1 here has an X, which is a don't care term. Output 2 and 3 will have zeros. And then at min term 3, output 1 should have a 1 and output 3. There. This is output 1, output 2, output 3. And at min term 14, output 3 should have a 1. This is output 3. And at 15, output 2 and 3 should have a 1. Wait, paano mag-pause?
Tapos na ba? Tapos na?
The logic circuit on the right um, is the reduced version of the original logic circuit, and the other one on the left is the implementation of 2, 3 to 8 decoders. As you can see, while this is a bit cleaner to look at, this will only have this part and this part be two ICs, while this will undoubtedly have more. I will now simulate the implementation of the decoder. So at min term 0, the decoder is at 0, min term 0, and the outputs are at all x, and at min term 1, the decoder is at min term 1, and the outputs are all ones. Min term 2, decoder is at min term 2, and the outputs are at x's. And at min term 3, there's still 0 up to min term 6. So that's 3, 4, 5, and 6. And at 7, all the outputs should be 1.
8, they should be all zeros, so you can see. And from 9 to 11, they should be all ones. So this is 8, 9, 10, 11, 12 should have zeros. But midterm 13, output 1 and output 3 should be 1. And at 14 only output 3 should be 1. At 15 output 2 and 3 should be 1. So
Okay lang yun.
this decoder works by getting the um, getting the min terms of the output that are high and connecting them to the decoder. So at 1, midterm 1, output 1, 2, and 3 are high. So this is the output 1, and as you can see, this is 1. It's connected to 1. It's connected to 1 here. It's also 1 is also connected to output 2 and output 3. Also with output 7, you will see the lines highlighted here. This is 7. And then for 9, 10, 11, this is 9. You can see this bulb. This is the output. This is the midterm 9. It is connected to output 1, 2, and 3. So if 1 is 1 in an OR gate, it will be 1 regardless the numbers of the 0. So it will output 1.